Oke, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everyone.
Morning.
How are you today?
Alhamdulillah.
Okay, so yeah, I'm fine. Thank you, Catherine, for asking me. And Shalom ya. Okay, sorry, my bad. Okay, so today, Alhamdulillah, we can gather again in this class with a healthy condition, and now we are going to start talking about next material. Before in the previous meeting we have discussed about reaction. What is chemical reaction? Okay, we have discussed about chemical reaction, and now we are going to together learning about stoichiometry. Okay, as you see in TV, you can see we will start talking about an introduction to stoichiometry, and we will understanding the chemical calculations, the simple one. Okay, so I will begin this class from questions. Okay, why do chemists need calculations in reaction? Does anybody know? No one? Okay, so let's find out the answer. So it helps chemists predict the amount of substances consumed or produced. So as we know in previous meeting, we have knew that there is a reactant and product. That's consume mean reactant, and produce it, what the substances that are produced is product. Okay, so it's simply reaction and products. And based on that, what is the definition of stoichiometry? The definition of stoichiometry is the calculation of reactants and products in chemical reactions. So who is the founding father? Then, who is the founding father of this stoichiometry? In history, we know that German chemist, namely Jeremias Benjamin Richter, was the first to define stoichiometry in 1792. Okay, my mistake. Okay, it comes from the Greek word stoicheion. It means element, plus metron, it means measure. So basically we are measuring the elements. So what is the purpose of our learning today? First we have to explain the role of the mole in stoichiometry, and to convert to moles into mass, moles into gas volume, and moles into numbers of particles. So we begin in the first thing. Okay, you just heard that there is a word called mole. What is mole? So this is the mole concept. A mole is a counting unit in chemistry. 1 mole means there is containing 6022 times, what is it? 10 subscript 23, superscript 23 particles. Okay, I don't know how to say pangkat in Indonesia. And what is molar mass? Molar mass is the mass of 1 mole of substances. For example, H2O. H itself, hydrogen, has a 1 grams per mole. Okay, and there is 2 hydrogen atoms. So it means there is 2 grams of hydrogen and 1 oxygen atom. It means that it has 16 grams per mole, and it's calculated that H2O has 18 grams per mole. Okay. Next, now we are going to discuss, or we're going to learn the central concept of mole. So the mole is the key unit in stoichiometry, And mole have a connection, have a correlation with mass in the grams, and gas volume in liters, and number of particles or atoms or molecules. But you have to pay attention in the second one, gas volume, okay? It's not only volume, but volume of gas and the gas form, okay? Mole means bridge between different quantities. So if we know a mole of some atoms or some molecules, we can predict how weight is it and how many numbers of particles in that atom or those molecules, and we can estimate too the numbers of particles. So this is the simple drawing or simple representation with if we have mole, we can convert it to many other form. First, we can change the mole into volume of gas. We can change mole of mass, and we can change mole to number of particles. Which means if this arrow means if arrow is going to there, but it means that mole. If we have mole, we want to convert it to volume of gas. We have to use this pattern. Okay, use this formula. So if we have 1 mole and we want to know how many volume of gas in that atom, we have to do this formula, and so on with the other. If we want to find mole to mass, and if we want to find number of particles, if we only know the mole of those particles, we can use all of this formula. And remember, simple expression. If you want to convert mole to others, it usually have to doing or maybe it usually mole is in the under of this formula. And if you want to going to the opposite of it, you have to put the mole in above this line. Okay, it will be very hard if we don't practice it in the basic case. So this is the example of the practice of this formula. If we know a sample contains 2 moles of carbon dioxide, okay, 2 moles of carbon dioxide, and the molar mass of CO2 is 44 gram per mole, how many grams of CO2 or carbon dioxide are present in the sample? So what are we highlighting in this case? We want to know the grams, right? The mass. We want to know this mass. And what have we known from this question? We know it moles and molar mass. If we want to convert mole to mass, we have to do this formula, right? Okay. So based on that, a sample contains 2 moles of carbon dioxide, and it has the molar mass of CO2. We can directly write it down. And Amel, what is the number of molar mass of carbon dioxide? 44. Okay, correct. 44 gram per mole. Yeah. And how many moles of carbon dioxide we know? 2. So yes, correct. So the answer is
22.
22, correct. Okay. 22, because there is mole and mole, we examinate them and it only stay gram. I'm sorry for my bad writing. Okay. So the answer is 22 gram. Okay. Anybody has question for this example? I think so. I want you to try another example. Okay. Does anybody want to be a volunteer to help me find the solution of this case? Who wants? The sample contains 2 moles of water. We have already know the moles. And the molar mass of H2O is 18 gram per mole. The question is how many grams of hydrogen oxide, dihydrogen oxide, or we call it water, are present in the sample. So this is the, oh yeah, sorry. So this is the thing that are questioned or that are asked in this question. Who wants to solve this? Amel, maybe? You can came forward and write down. Okay.
First, write the formula.
Molar, yeah. Write the formula first. Okay, great.
So, this molar mass difference.
Yeah. You want to erase it? Still? Oh. Right sample. Oh, still. I don't know how to use it. You can just maybe scratch it if you don't want to. What? Wait. Oh, it's already. Give it a try. Okay, give applause for Amel. So the molar mass we know is 58.5 gram per mole, and a moles of sodium chloride is only 1 mole. So it basically, the answer is the molar mass itself. Okay, so the answer is correct. Please give applause again to Amel. And now we moving to another example. Maybe the last volunteer. Who wants to be a volunteer? Oh my God, I forgot. I already erased that one. Okay. Okay. So thank you for listening, guys. Today, I hope that you can understand all of the explanation and questions. If there any mistake for me, for example, that just happened, I forgive it at the deep side of my heart. Thank you for listening, and tomorrow we will discuss more about stoichiometry and how to practice it in chemical reaction. Okay?
Yeah.
Okay. Maybe last to make sure. Does anybody has question? Okay. Okay. Thank you for listening, guys. Hope you have a great day, and hope that we can meet again in the next meeting. I close this session. Assalamualaikum warahmatullahi wabarakatuh.